All right, so for today we're going to look at the last section, which is graphing systems of inequalities. We already know how to graph a system of equations. We already know how to graph inequalities independently, so now we're just putting those two pieces together. Okay, so a system of linear inequalities is two or more linear inequalities. And remember, an inequality has a less than or a greater than, or a less than or equal to, or a greater than or equal to. So we're looking at these symbols. That's how we know it's an inequality and not an equation. Okay. An ordered pair is a solution. So just like to a system of equations, an ordered pair is a solution to a system of inequalities that makes the system, or makes all of the inequalities in the system a true statement. Okay, also known as the overlapping section of two linear inequalities. Okay, so what we're going to do is we're going to graph them and we're going to shade, and there's going to be an overlapping section. Okay, so the first thing is when we're graphing an inequality, we need to determine if the line is dashed or solid. Remember, dashed or solid. Remember, we have dashed lines and we have solid lines. Dashed lines don't have the equal to symbol underneath. Solid lines do have the equal to symbol underneath. So we're going to graph the line. Remember, it needs to be in y equals mx plus b form, where I have my y-intercept and I have my slope. So we're going to graph just like we did starting from Unit 6. And then we're going to shade above or below the line based off of our inequalities. Remember, above is our greater than symbols, and below is our less than or equal to symbols. So if we put that all together, here are your examples. Notice how we have a less than, less is below. Less is below. Also, there's no equal to underneath, so note I have this dashed line. Okay, this is a less than or equal to symbol. So since I have the equal to, that means that I'm going to have this solid line. And again, it's less, so we're going to shade below. Remember, that means go to your y-intercept and shade below the line. To the y-intercept, shade below the line. For the next one, we have a greater than, greater is above. So if we go to the y-intercept, we're going to shade up from the y-intercept, and our greater doesn't have an equal to, so it's a dashed line. And then over here we have our greater than or equal to, so that means that we have solid. So note it's solid. And then it's a greater, so it's above. So I go to my y-intercept and I'm shading above the line, which is why everything kind of to the right and up is shaded. Okay, so what we're going to do is we're going to determine where the shading overlaps for all inequalities. So if I take a look at this equation, this inequality, my y-intercept is at -2. And I'm going to go slope of -1. So my b value is -2. My m is -1. So that's down 1, right 1, down 1, right 1, down 1, right 1. This is going to be a dashed line. So I'm going to go ahead and I'm going to dash that line because it doesn't have an equal to symbol underneath. Now, this is going to be, because it's a greater than symbol, I should be shading above. Now I'm not going to shade yet, okay? The y is less than or equal to 3x plus 6. So if I take a look at the other one, so I have a b value of 6 and an m of equal to 3 over 1. So I'm going to start at positive 6, and I'm going to go up 3, right 1, and I'm going to go down 3, left 1, and this is an equal to underneath, so I am going to use a solid line. Okay, so I graph all the way across. And now this is a less, so that means that I'm going to go below the line. So I think of this as there are 4 different regions. If you can kind of see, I have a region here, a region here, a region here, and a region here. These 2 lines create these 4 regions. One of these 4 regions is going to be shaded based off of where it has to meet both criteria. So for the blue line, I'm above. So above the blue line is region 1 and 2. Below the purple line is region 2 and 3. Well, what's the overlap? So if above is regions 1 and 2, and below was regions 2 and 3 for the purple, then the only one that's in there twice was region 2. So region 2 is my overlap, and that would be the region that I shade. So I shade up until those 2 graphs. So any point in this region is a solution. So I could put a point here, that's a solution. I could put a point here, that's a solution. I could put a point down here, that's a solution. Because what happens is we take these xy values, so this would be 5, -4, and I would plug that into both equations. So -4 is less than negative of 5 minus 2. Sorry, greater. -4 is greater than -7. Yeah, that's a true statement. If I do the other way, -4 is less than or equal to 3 times 5 plus 6. Well, that's -4 is less than or equal to 21. Yeah, -4 is less than 21. So that's a true statement. So any point in the pink region, any point in the pink region is a solution. Okay, now if it is a point on the solid line, it counts as a solution. If it is a point on the dashed line, it is not a solution because the dashed line would not make the inequality true. Okay, so I'm going to also add that. Points on solid line are solutions. Points on dashed are not solutions. Okay, so that's going to come up later and on your assessment. Okay, so if we look at number 2, I'm just going to go through a quick example of this again where we can kind of see. So I'm going to plot, so my b is 3 and my m is up 2 over 1. So I go to positive 3 and I'm going to go up 2 over 1, up to right 1. This is a dashed line. Okay. Then I have, this is going to be below. Then I have y equals -3x plus 2. So I have a b value of 2 and an m of -3 over 1. b of 2 and an m of down 3, right 1, down 3, right 1. This is a solid line. Okay, and I have now, and this is greater, so it's above, 4 regions. So I can call this region 1, region 2, region 3, and region 4. Where are the solutions to the purple line. So below the purple line, go to the purple, 2 and 3 are solutions. So 2 and 3 satisfy the below. Above the green line is region 1 and 2. 1 and 2. Well, what region is in both of these? 2 and 2. So we would shade everything in region 2. So that's defined by the boundaries of the line. Okay? Hopefully that makes sense. We're going to skip the U tries. Couple of things to remember that I noticed in some of your homework assignments. Remember that if I have x equals, that's a vertical line, and if I have a y equals, that's a horizontal line. So if I'm looking at x is less than 3, this is an x equals, so this needs to be a vertical line through 3. So I would go to 3, x equals 3, and I'm going to put some points, and I'm going to make that vertical line. It's a dashed line. No, that's not 100% straight. It's pretty close. And because we are less than, this is going to be to the left. Now, this is the only case where it's not like above, below. It's left because values left of 3 are smaller or less. Okay. Then the other one, 2x plus y is less than or equal to 2. I need to solve for y. So I'm going to have y is less than or equal to negative 2x plus 2. And I need to go ahead and change colors here. So I'm going to put a positive 2 down to right 1, down to right 1. And this is going to be a solid line. Okay. You're always going to have 4 regions defined. Okay, so if I draw in my regions, and it doesn't matter how I number them, so in between here is my 4th region. So left of the purple line is 2 and 3, and then less is going to be below the green line is 3 and 4. So here's my green, my green line is 3 and 4. So below it are the 3rd and the 4th region. And so what's the overlap? Region 3 is my overlap. So therefore my solution is everything up until the 2 lines. Okay? And so any point in these regions is a solution. This point right here, yep, that's a solution. However, come back. This point right here is not a solution because remember it's on the dashed line. So that would not be a solution. Okay? All right. And so then this example is just kind of going through the same thing. Is the point 4, 1 a solution? So if I go to 4, 1, that's on the dashed line. So no, it is on the dashed line. So that would be E. For negative 1, negative 5, that's this point here. It's on the solid line and it's bordering the shaded region. So yes, it's on the solid line bordering the shaded region. So that's C. Negative 4, negative 6. So here we are down here. This is, now it's kind of hard to see, but this is the first graph. This is the second graph in blue. This is the overlapping region. So we're talking about points in that area. That is in the shaded region. So that would be A. 6, 4. 6, 4, although it's, 6, 4 is, no, it's not in the shaded region. And then negative 2, 4, negative 2, 4 would also be a no. Even though it's in a shaded region, it's not in the shaded overlapping region. So not in overlapping shaded region. Okay, so those points are not solution. So that would be no again. Okay. All right, so that's your systems of inequalities. I'm not going to go through any more examples. I want to keep the notes relatively short. So if you have any questions, reach out via Remind or email. Okay. All right. Happy day.